So for most of you, this should be a review based on the fact that a prerequisite for the Windows Client class is the CIS 179 Network Essentials. But let's go ahead and just go through the idea of configuring IP settings. Now, as we talk about configuring IP settings on a network that is based on the Windows network operating system, and of course, in this case, Windows 8, it certainly applies to Windows 10 as well. So we'll just talk about network basics real quick. You know, what is networking? It definitely is one of the primary functions of Windows 8. It's the primary function of the internet. You know, the idea of interconnecting all these computers together, being able to create private local area networks to share data, connect to the internet, all of that good stuff. And of course, you know, right now we're in sort of a big change in that we have this idea of IP version 4 and IP version 6, which we'll take a look at here in a minute. So, you know, in doing all this networking, we need different means of communicating. Those are protocols, you know, languages that all computers understand. Of course, protocols and the protocol stack can differ depending on what kind of network functionality we're using, as well as applications that we're using, etc. So, you know, most common method for illustrating the operations is the OSI model. So, you know, the 7-layer model. Let's take a quick look at that. I always like to remember this as all people seem to need data processing. So that's application down to physical. Some people do the physical layer and go up to application. Please do not throw sausage pizza away. So all people seem to need data processing. Please do not throw sausage pizza away. So those are two ways to remember this idea. And of course, we start with the physical. And in troubleshooting, folks, this is where you should start your troubleshooting, is the physical layer. So many people jump on the computer and start using ping and start seeing if it's connected, where my high suggestion first thing is, are you connected? Is the computer connected into the back of is the Ethernet cable connected to the back of the computer? Are the lights flashing? Did somebody disconnect it on the other end from the switch? So, you know, a lot of times I've seen folks get so wrapped up in trying to make sure that the network interface card works and etc. And as you do this lab, keep that in mind, you know, as you're pinging out. What are you pinging? Are you pinging the loopback address? If you're using 127.0.0.1, all you're doing, you're not getting out to the network with that, okay? All you're doing is checking, can the computer communicate with the network interface card? That doesn't mean it's connected to the network, so keep that in mind. So the physical layer, the cable, or now, you know, most commonly the radio signals, definitely. You know, wireless, Wi-Fi. We're connecting a lot of computers and devices, not just computers, but devices, wirelessly to our network. You know, so we understand what a network interface card is. You know, the data link layer, again, I'm going through these quickly because you should have had these. If you need to, go ahead and pause and review this information. So as we move up from the physical to the data, you know, Ethernet, the protocol responsible for addressing packets. This is how we take those files and explode them into little packets that are easily transferable and that can be rebuilt on the other end. Now, of course, I like to use the analogy of a letter going through the post office. You know, what's the header? What's the footer? You know, how do we know where to send the information back? So, of course, we put that in a frame. So we have the data link header, the network layer, you know, the data link footer, and we move up the protocol stack from there. So the network layer protocol, you know, Windows uses by default as the network and transport layers to collectively called TCP/IP. So why does Microsoft use this? Because this is the worldwide standard, right? Transmission control protocol, internet protocol. So we can send all those magic packets, not only routing them through our local area network, but routing them out to the internet, out to computers on the internet located throughout the world. So IP routing, you know, a router, a device that connects one network to another. Yep, and through that router, we can create security boundaries. We can route just particular protocols that we need to route. We can prioritize protocols so that they route first. A lot of great things we can do with routers. And of course, routers are different than switches, right? So you should by now understand the difference. So when you install a LAN in a home or office connected to the internet, you're actually installing a router that connects your network to another network. So that modem that we get, is in a certain aspect also a router. It's going to route traffic. It gives us a gateway IP address that connects us to, say, the Ben broadband network, and from the Ben broadband network, we go out that way through the internet. So 2 types of addressing, as we talked about. Current standard, still IPv4, defines a 32-bit address space. Each address is split into 2 parts. So we have the network identifier and the host identifier. So the network identifier specifies the network on which a particular system is located. And of course, the host specifies a particular network interface called the host on the network. So our IP address is made up of multiple parts, letting it know what network it can connect to and then what the address is. So should be familiar with Subnet Mask, class A, B, and C. Class C, that 192.168 that we use for a lot of stuff. That's the one that most of your home routers use these days. I always tend to change that just from the aspect of, if I've got a Linksys and everyone else is using that, then you know what mine is as well. So, class A, what some folks will do, I do this myself, I might take a class A, subnet it down to a class C so that I can use a class A addressing schema, okay, and subnet down to a class C subnet, just to create an additional security layer. I don't just use the standard class A, by the way. So, you can see the difference, the number of hosts. Do I ever suggest setting up a small business with class C? No, I don't. When I worked for a growing company, that's what they did. They set it up as a class C, and unfortunately we outgrew it, and now we have all these computers, both statically assigned and DHCP assigned computers, that needed to change. We essentially ran out of addresses. So you never know when a company's going to grow. Class B, first of all, if you set it with a class B at the start, there you are. Number of network identifiers, number of host identifiers, number of possible networks. So as we look at routing internally to create security boundaries, we can create a lot of security boundaries. And realistically, how many hosts are we going to need on a single network? So classless interdomain protocol, or CIDR, differs to from the traditional addressing, now called classful addressing, by allowing the division between the network identifier and the host identifier to fall anywhere in the IPv4 stack. So we're no longer limited as to where that has to fall, how many bits we have to use, etc. So go ahead and pause this if you like. It'll give you some examples of IPv4 addressing. Now with IPv4, okay, let's just briefly talk about the idea of ways to set up these IP addresses. The fact is, there are times that and best practices for manually configuring IP addresses, servers, access points, for example, even clients that might be used for services that are network services. For example, we might use a client to set up an application that people need to get to, but we ran out of servers or whatever the case may be. We definitely want to manually configure IP addresses on servers. So you can see by doing these manual configurations why planning IP addressing is so important. You don't want to have to go back and change all these databases that are referring to manual IPs or routes to ODBC over IP, stuff like that. Certainly, though, we don't want to have to manually configure and manage every IP address, and that's when DHCP comes in handy. So most likely on your home network, you might have computers that use DHCP either from the modem /firewall /router that Ben Broadband gave you, or in my case, I do a bridge through to a better, mid-sized business router and firewall that I like, and use that. So DHCP, can become pretty important. We do need to manage it. We want to make sure we have just enough IP addresses for the computers that are connecting, plus maybe a few guests. But it's certainly highly convenient, and much more convenient than going around and setting IP addresses, especially if it's a laptop that you're taking and then connecting to other networks. You want it to get an IP address from the other networks as well. And then, of course, I'm sure you all have seen APIPA addresses. The idea that I can just magically somehow connect two computers and they can talk to each other. Why? Because they assign an APIPA address. They go out and make sure that APIPA address is not being used by another computer, and it magically happens for us. So DNS, by now you've used the web, you've got 179, you should understand DNS. Really the whole idea behind DNS is to convert an IP address that we don't necessarily have to remember to a name. And the thing is, we can then easily change the IP address through DNS configuration to address another computer. So this is the idea of, back before DNS, we had host files, and you would have to put a host file on a computer, and that host file would say, hey, if you're looking for this name on the network, that is actually this IP address. So no longer do we necessarily need host files. DNS does that for us, and as we know, DNS is what allows us to do simple things like go to a web browser and type in www.google.com versus having to remember one of many addresses for Google. So this brings up the new technology, the IPv6. Why did IPv6 come about? Well, because, frankly, IPv4 only allowed for about 4.3 billion interconnected computers, 4.3 billion unique IP addresses, and we are running out. Who would have ever thought that on one network, the World Wide Web, we would need the ability to route to 4.3 billion computers? Now, we do understand that with firewalling, with NAT, with creating our own private IP addresses and a gateway out to the web, not every computer in the entire world needs a static, unique IP address. So, this brings up, the idea that we needed to expand that. Now, I went out here and did a little something here. This is an IPv6 address. Now it's giving me a little bit different number than what you're going to see. But here, if you notice, IPv4, pool of 32 bits. So, 232 in size, contains 4.2 billion. Basically, 4.294, you get the idea. IP addresses. Then there's IPv6, which gives us this huge number. Now, what we call that, by the way, is it gives us 340 undician, I'm not sure how to pronounce that. I'm going to have to look that up. Addresses. What does that mean? Well, basically there's enough addresses for us to give every device that needs a unique IP address a truly unique IP address. So IPv6 addressing can be very difficult to understand. It's different. Up here we did binary. Here we do hexadecimal notation. So the idea of learning and understanding hexadecimal comes back into play. It really is easy, though, because you can create very simple IPv6 networks. As soon as Ben Broadband supports IPv6, I can move to IPv6 on my home network and start playing with it. But, basically, I can have a simple network, and the ones that don't can be all zeros, in which case I just put the colons together. I don't have to do anything with each and every set. So Windows 8 does support IPv4, IPv6. Most devices coming out today do support both. If not all of them, they should. So Microsoft calls it their Windows 8's dual IP stack, because basically it will understand both an IPv4 or an IPv6 address. So, as you can see, with both checked, we can configure both. This way, what we can do is start adding, and using IPv6. Of course, it's already being tested on the World Wide Web. It's already being used by a lot of companies, so that they don't have to move over. So IP adds its header. So back to the idea of that stack, it sends a packet down the data link layer. Ethernet adds its own header and footer, and off we go. So we get a nice, graphic of that. So notice here was our data link header. Then we go to the network. We have the payload, which is going to include the headers, and off we go. Transport layer, two types of transport: connection oriented. So two systems communicating establish a connection before they transmit data, and then connectionless does not require the establishment of a connection, nor does it perform error detection. So which one is a broadcast? I'll let you figure that out. So other things we look at: ports and sockets. So protocols tend to go over specific ports. You can think of a door with thousands of holes in it, and with the firewall we can open and close ports that we know we need protocols to go through, or that we don't, so that we can secure our network and not keep ports open for scanning that that we don't need. So let me give you an example here real quick. So here's a site that I really like, Gibson Research Corporation, grc.com. SpinRite, you might look at that. It's a data recovery software. It's really cool. But we're going to look at Shields Up